Many times we encounter surfaces with waves in them or visible lines in them. For example, this key has vertical lines we can see from the milling process that made this channel. What we can also see in this key are a series of finer horizontal lines. This becomes an interesting problem where we can use software tools like OmniSurf3D to separate the longer waves from the finer lines. So here's a measurement of that surface, and we can see the longer waves that were running up and down on the screen along with the texture of the finer lines. So let's walk through how we would analyze this using OmniSurf3D's interactive filtering tool. So first off, we can see that the raw data is tilted, so I'm going to go into my geometry and choose a plane. And OmniSurf3D gives us this great visualization of what the preprocessed surface along with the geometry looks like. So we can see the plane as a transparent glass plane, and that looks like a good geometry to remove. So let's look at the form removed surface. Now, many of you are familiar with the profile sectioning tool, where we can drag a plane around through the surface and get a cross-sectional profile. This is very useful. There's also a tool that you may not be aware of. If we hold the alternate key down, it keeps the plane along the x-axis. Similarly, if we hold the shift key down, it holds it along the y-axis. If you think of the lower left of your keyboard like a little x and y axis, you'll see the alternate is along the x and the shift is along the y. So we have a nice profile section through here. Let's turn on a new tool though. It may be new to you. It's something I use almost every day in my work, the Wavelength Content view. Now you'll notice the toolbar icon up here at the top has a little box in the lower right, and it indeed adds a little box to the lower right of our screen. And this gives me a plot of all of the wavelengths in the surface and how strong they are. So for example, if this surface was made entirely of sine waves, one of those sine waves right here at this amplitude is much taller than the others. In fact, this spike, this peak right here, relates to the spacing of these scallops we're seeing with our eye. So if we were to filter to try to find just that feature, it would be really interesting to put a filter band around this feature. And that's exactly what OmniSurf3D's adaptive or interactive filtering can do for us. We can use cursors, use those red cursors as our new filter band, and we can filter and isolate just that wavelength domain. So we can see now that we've filtered into this band. Well, right now I'm showing the form removed surface, so let's add a new view and take a look at that filtered surface. So that is the filtered waveform looking at this band of wavelengths. Now these two are on different scales to start with. If you notice, this is a plus or minus 20 micron scale, this is plus or minus 10. They're both auto scaling. So let's use the chain link tool here on the toolbar to link the right view with the left and synchronize them. So now they're at the same scale. This is very interesting. This shows me the waviness of this surface. Now what we could do, once we have this set up and we're happy with this waviness, we might tune it a little bit and say, let's look at this zone, use the cursors as the filter band, and we'll see how the filtered data changed a little bit. We can see the actual numbers. The short cutoff, 0.4 millimeters, the long cutoff, 1.6 millimeters. Those are the filter settings that we could perhaps manually set someday. We could set 0.4 if we wanted to be on a nice number, and 1.6 if we wanted to be on a nice number, and okay that. And here's our analysis again with those new values. But these are nice clean numbers that we could communicate to someone else. Well, let's go back to this surface, and there are individual lines, the fine textured lines. Those are made up of all the wavelengths over here on the short wavelength side of the spectrum. So if I put my right cursor where the transmission crosses 50%, let's say, and put my left one here, let's use this cursor zone as a filter band, and we will be able to remove the lumps now and show just the fine details of the surface. So it's a great tool. We can interactively choose different areas of the wavelength domain, use the cursors, and immediately see what that band of waves looks like in a surface. And like any other surface analysis, we can put parameters on this. For example, we can look at the SQ of that band of wavelengths or add any of the other parameters. So OmniSurf3D gives us a better way of finding a wavelength domain of interest. If you have questions about your surfaces, give us a call, hit the Contact Us link on digitalmetrology.com, and we'll be happy to help.